let's move on. Okay. So our recording has started. We can begin today's lesson. Okay. So once again, in today's lesson, guys, we are going to be looking at your grade 12, obviously, but we are looking at cubic functions. So we'll have a look at a couple of exam questions to better understand how cubic functions work. Okay. Let's go ahead and begin. So I'm just going to be taking you through a very brief intro before we go into questions. And remember, we're looking at cubic functions. So the first thing that I need you to understand is the definition of a cubic function. Okay, and this definition, we are going to call it the standard form. So the standard form of a cubic function. So how do you see that a function is a cubic function? It's a cubic function if it takes the form f of x equals ax cubed plus bx squared plus cx plus d. This here is what we call a cubic function. Why cubic? Because the highest power or the degree, rather, which is the highest power of x is equal to 3. And you guys know that 3 is a cube. Okay. So that is why this is a cubic function. So you have the standard form, but you also have another form of a cubic function. So they can either give it as that or they can give it in another form. So what is the other form? They can give us our cubic function as g of x equals a into x minus x1 is an example, x minus x2, and then x minus x3. So this here also still represents our cubic function, okay? Where what you should see is that we have factors here, where what we have, which is essentially x minus x1, x minus x2, then x minus x3, these are vectors of the function that we are working about, or we are working on, which in that case is g of x, okay? So that is just about it. They can give you a cubic function either in this way or in that way, okay? Now, what we need to really appreciate is the shape of a cubic function. Okay, so the shape of our cubic function, and what we are going to look at is just use f of x, okay? We'll use this one, ax cubed plus bx squared plus cx plus d. So our cubic function can be in two ways. So it can be something like this. So it can look something like this, okay? Or it can look something like that, okay? So when we look at the right-hand side or the left-hand side, when our cubic function is like this happens when the value of a is greater than 0, meaning when a is positive. Look at the a we're speaking about. We're speaking of that a. Okay, when a is positive, our graph looks like this. But when a is negative or less than 0, when a is less than 0, which means when it's negative, then our graph looks as we can see below here. Okay, so I hope that you do understand that. And by looking at the graph, already you are able to see if the a is going to be positive or negative. So here we're speaking about the shape, okay? We determine it using the value of a. It's very important, guys. Then what I need you to be aware of next is turning points. So speak about turning points. So we are looking at turning point of a cubic function. So how do we deal with turning points of a cubic function? Well, we still have our f of x equaling ax cubed and plus bx squared plus cx plus d. So if you look at our function, you will see that it has 2 points. So it has 2 turning points. So if you remember, we have one of our functions looking this way. So what you should see is this important note. And the note is that f of x has 2 turning points. F of x, which is a cubic function, so it has 2 turning points. Okay, and if you look carefully from the sketch, you can clearly see that. Okay, that we have a turning point here. This here is a turning point. We'll call it turning point 1. And there's another turning point here that we can call it turning point number 2. So that is the property of a general cubic function. There's exceptions, but we'll have a look at them. While we are speaking about the turning point, you should understand, you guys, a very important question, which is how do we find the turning point of the function which we have above of f of x? Okay, and the answer to this question is as follows. So our answer will be, what we do is we derive, we find essentially f prime of x, and then equate it to 0, then solve for x. Then after getting x, what you do is you plug the x into our given equation, which is f of x for the y value. That is what you're going to do. So to find the turning point, we must find f dash of x. And remember, all what this speaks to, guys, is deriving. So what we'll do is we'll derive. And how are we going to derive? We are going to use something which you know. Use the power rule. That is what we are going to do. We are going to use the power rule of differentiation, which we would have covered in earlier lessons. So you use the power rule of differentiation, and then you equate to 0, and then you solve for x. Okay, that is what you're expected to do in order for you to find the turning point. So for example, if you look at the f of x we are given above, if we're looking for f prime or f dash, which is the derivative, the 3 will multiply down so that we have 3a x. Then we minus 1 from the 3, meaning we are left with a 2. So we have x squared. Then if you look at the other one, we'll have 2b x and then plus c. Derivative of a constant, remember, we said it is 0. So it means if we want the turning point, this is what we are going to equate to 0 and then try and solve for x, which will give us the x value of the turning points. Okay, so I hope that you guys actually understand this. So we're looking at turning points of a cubic function. So now that we understand the turning points, let's quickly go to the x and y intercepts. So what we are looking at now, it is the x and y, but let's focus on the x-intercepts more because they're a bit deep. So let's look at the x-intercepts of a cubic function. Okay. So remember your cubic function, standard form, you have f of x equals a times x cubed plus bx squared plus cx plus d. So whenever we are looking for the x-intercepts, what we should do is set y to be equal to 0, which means we'll have ax cubed plus bx squared plus cx plus d, and this will be equal to 0. So in order for us to solve for the x-intercepts, what we are going to do, we are going to guess a solution. Guess a solution. So what does this mean? It means that we are going to try different x values and see if we can get 0. So we are going to try different x values to eventually get 0. Okay. So you just need one x value to work, and then the rest will do long division. So here, what you need to do is get one x value that works. So we get one x value that works, and then do long division or use other methods. We'll do your long division or use other methods. Okay. And then the rest of the things, it just becomes analysis. Okay. It becomes that. But what I want to do also is to cover a special case of the quadratic, not quadratic, but cubic function. So I'm going to look at a special cases. So the first special case we are going to be dealing with is f of x equals x cubed. So what you should note is that here we have no, or the turning point is at 0. Okay. So rather not say we have no turning point. So how this graph looks is as follows. If you observe carefully, if you remember, we said when our A is positive, your graph goes something like that. Okay. So because now the A is positive here, so our graph will become what just happened now. Okay. It's very strange. Let's quickly fix that. Put in another axis. And let's go ahead and draw our graph. So if you observe carefully and you go and watch or you look for this cubic graph, you'll see that it becomes something like this. And this is y equals x cubed. Okay. And then you can obviously later move it up and down these axes. Okay. Someone else now can go and move it up by simply adding a 1. What do I mean? Well, what I mean is this. You just shift it up like that, and it crosses, let's say, at 1 here. Then that now becomes y equals x cubed plus 1. Okay. And you can have another one where you just push it down by 1 and so on. But the y equals x cubed is just one which I wanted to just bring to your attention. Then if you observe carefully, you can obviously have the negative 1 where it becomes something like this here. Okay. And this one here, the green one, would be y equals negative x cubed. And you can shift it however way which you also want. Okay. Now with this done, guys, I think we can go and try some questions. We'll learn while practicing. Okay. So with this now, out of the way, let's go and have a look at this question here, which is the November 2025 exam. So let's zoom in. So the question or the statement reads, sketched below is the graph of f of x, and they tell us A, B, and C are x-intercepts of f, and then D and E, as you can see, are turning points. So what we are asked is to calculate the coordinates of E. So if you look carefully, E is the turning point, guys. So let's go ahead and look. So we have 9.1. So we're looking for the coordinates of E, and E is the turning point. And you remember how I said you guys should find the turning point? For the turning point, we need the derivative. So we need f prime equal to 0, and then we solve for x. So that is what we need. Then we take the x, plug it back to the original equation. Now, if you observe carefully, we have our f of x function given as x to the power of 3 minus 8x squared, and then plus 5x plus 14. So I need to go and find f prime of x, which all what it is, it's just the derivative with respect to x of all of this here, of f of x, okay, like that. And what we are going to do is to use the power rule, okay? So f prime, power rule says we should multiply by 3 down, which we're going to have 3x. Then we minus 1 on the exponent, okay? Which then leaves us with an x squared. Then we take the 2, we multiply by it there, it becomes 16. And then we minus 1, so 2 minus 1 becomes 1, okay? And then plus 5 to the power of 1, if you multiply, you get 5. Then you minus 1, it becomes x to the 0, so we get 5. Then derivative of 14, which is a constant, this is going to be 0. So I need you to go and revise your calculus, okay? So now that we have this, we are going to go and equate it to 0. And what we are looking for now is the x values of the turning point. So let's go ahead and look at the x values of the turning point. Let's call it the BP. Okay. So we are just going to equate this to 0. So we are going to have 3x squared minus 16x plus 5. This should be 0. And guess what? We are looking for x here. So what we are going to do is we are going to use the quadratic formula. So I need you guys to quickly use your calculators. So we're going to use this quadratic formula. Okay. We'll create some space here. Put this up. So your quadratic formula will be x equals, it will be x equals negative b, which is negative 16, plus or minus the square root of, you observe carefully, negative 16 all squared, minus 4 times a, that's 3, c, that is 5, and all of this is divided by 2 times a, which is 3. So what do you guys get when you use your calculators for this one? So let me quickly put up mine. What are you guys getting?
So 5, x is equals to 5.
X equals 5 and what? Other one.
1/3.
So x equals 5 or x equals 1/3. Okay, thanks for that. So carry on then and have a look. So now we are looking for the coordinates of E. So between x is 5 and x equals 1/3, which one is the coordinate of E? So if you observe carefully, E is on the right. So it means the x of E is 5, okay? So the x of E equals 5. So now we need to figure out what is the y of E. And for the y of E, we are going to use our equation by substituting x is 5. So y of E will be f of 5. So meaning wherever we see x, we put in 5. So we'll have 5 cubed, then minus 8 into 5 squared, then plus 5 into 5, and then plus 14. So I need you guys to quickly do your punch in there and give me what is the y at E.
Negative 36.
Negative 36. So therefore, we now have our coordinates of E, which is just 5 and negative 36. Okay, just like that, we are done with that question, guys. Okay, so now let's go to the next question and see how we deal with that question. So this here for this question, which is 9.1, that becomes our answer. Those are the coordinates of E. So let's go to the next page and have a look at the next couple of questions. Right. So for this, we are asked for which x values is our function concave up. Okay. So for this one, what we actually need is something that we have not touched. So 9.2. Okay. So in 9.2, guys, there's something that we call the point of inflection. So I'm just going to say division here. So there's something that we call the point, which you would have been exposed to in class, the point of inflection. So really what this point is about, it is where we change. So this is where we change from, let's say, concave up to concave down. Okay. And then now the question then becomes, now that we know the point of inflection has to do with concave up and down, now the question becomes, how do we find it? How do we find it? And how we find this point of inflection is by having the second derivative of x equaling 0. And then what you can do is you can solve for x and then y, okay, the corresponding y value by plugging back. So when they're now asking us about our point of inflection, where is it where the x values are less than where it is concave down, we need to remember if our second derivative at x is less than 0, does this mean concave down or up? Do you guys remember? Any one of you?
Is it concave down, sir?
Are you sure of that answer?
No.
Can guess it. Still taking a guess. Anyone else? What are your thoughts? If our second derivative is less than 0, does it mean we have concave up or concave down? Other guys, where are you at? Okay. So when it's less than 0, yes.
You said I was confirming that it was concave down.
Yep. So if our second derivative, if we make it to be less than 0, at that x value, it means that we are concave down. Okay. And equally so, if our second derivative at x is bigger than 0, then what we are going to have is concave up. There's going to be concave up at the x value, whatever the x value is. And then, what we spoke about on the previous page, if our second derivative is now equal to 0, where we are at now is where we call this the point of inflection. So on the left of the point of inflection, we are either concave down or concave up. Okay, so this means for our problem, we need to figure out when is the second derivative less than 0, sorry. So remember that on the previous page, we already found the first derivative. So we have the first derivative, which we found on the previous page, of which it is 3x squared minus 16x, and then plus 5, I think. Yeah. This, remember, what happened is we found previously, we found in 9.1. Now, for us to find the second derivative, f dash dash, it means we now need to find the derivative of this first derivative, for us to find the second derivative. And again, we are going to use the power rule, guys. So if you look carefully, we'll take down the 2 so that it becomes a 6. Then we minus the 2 with the 1. We are left with x. Then this becomes minus 16. So this becomes our second derivative. Now we need to figure out when is our second derivative less than 0, for which x values, because that is what they're asking us there. So it means we need to take then 6x minus 16, say it is less than 0, and guess what? Simple maths, we can transpose such that what we end up having is 6x is less than 16. Guess what? We can do division by 6. So divide by 6, divide by 6. So you will see that our x will be less than 16 divided by, of which this here, when we simplify it, it will be x is less than, so there's a common 2 which will divide, leaving us with 8/3. So this here comes our answer. Okay, you guys understand? If you do, give me a thumbs up. You following? Okay, cool. I see that we good. So let's move on then to the next question. So what I'm gonna do is to just create an extra page. Let's move this one down. Then let's go and finish the remaining questions. Okay. So now we are asked the coordinates of B, or we are told the coordinates of B are 2 and 0. Okay. So they're telling us that here at B we have 2 and 0, meaning they've given us one x value. Use the graph to determine the other x values for which f of x times the second derivative at x is less than 0. Okay. So what we need, guys, if you think carefully, is the x values at C and the ones at A. Then we can go ahead and do this analysis. Okay. So let's go ahead in 9.3. So what we need to find is find the x values at C and A. Okay. We can find the x values at C and A, then we are done. But already we are given one intercept. So if you observe carefully, we're given one x-intercept, which if you observe carefully, it is x equals 2. So when you go to your equation, your f of x, which is given by x cubed minus 8x squared plus 5x plus 14. If you substitute the 2, you'll have 2 cubed minus 8 into 2 squared plus 5 into 2 plus 14. What you will realize is that it will give you 0. And whenever it gives you 0, what this means is that x minus the number that gives you 0 is a factor. So therefore, it means x minus 2 is a factor in this expression. So now we need to find the other factors. So that is the question we are trying to answer, which is what about the other factors? And for the other factors, what we are going to do, there's a lot of ways you can go about doing this thing here. And I can show you a couple of ways. Others would prefer to do long division. So I'm just going to quickly do that. Do long division. And there's many ways you can go and sort this out. So with our long division, what we have is x minus 2. And it is dividing our entire expression, which is x cubed minus 8x squared plus 5x, and plus 14. Okay. So what we are going to do now with long division, you guys must revise it unless you have an alternative method. You can say x cubed divided by x, and the answer which you get is x squared. Then we always put a minus and a bracket. You take the x squared, you multiply whatever that is down there. You say x squared times x, that becomes x cubed, then minus 2x squared, like that, okay? And now if you do the subtraction, you do the top minus this bottom here, you'll see the x cubes will cancel. And what you are going to have is minus 8x squared. This negative is going to make this 2 to be positive, making it to be minus 6. So we have minus 6x squared. The other terms have no terms to cancel with, so they come down as they are. That's 5x plus 14, okay? And then again, we do long division. You take this here, you divide it by x. So negative 6x squared divided by x, that gives you negative 6x. Then you take negative 6x, you multiply it down there. Okay. You take that minus 6x, you multiply it down there. So we put in a minus, then you open. Negative 6x times x, that becomes negative 6x squared. Then negative 6 times negative 2, that becomes plus 12x. Okay. And then again, we do our subtraction here, and terms are going to cancel. Okay. So this term and this term, they are going to cancel to 0. When you distribute the negative, then you'll see you have 5x minus 12x. So 5x minus 12x, that should be 7. I think 5 minus 12 is negative 7. So we have negative 7x. And then the 14 comes down, plus 14. Then guess what? What you do, you take the minus 7 now, you go and divide the x. And then your answer ends up being minus 7. Then you put in the minus. You take the minus 7, you multiply it this side. You take the minus 7, you multiply it here. So minus 7 times x, that becomes minus 7x. And then minus 7 times minus 2, that becomes 14. And guess what? When you subtract this, you get 0. And this is when we stop. We stop when we get a 0 with long division. Okay? So that is what happens. Stop when we get a 0. That is when we stop. So what this means is that what we have there at the top is our factor. So this means, therefore, our f of g or our f of x will be, remember we said x minus 2 will be a factor. And then whatever that sits there at the top, that becomes the other expression, x squared minus 6x minus 7. Okay, So now you can factorize this if you look carefully. Guys, you have x minus 2. This one here should be very easy. It will be x minus 7 into x plus 1. Okay, it's grade 9 maths. And then now you can find your solution. We equate this to 0. You'll see that you'll have 3 x's. You'll have x equals to 2. Or you put commas, you'll have x equals 7, or you'll have x equals negative 1. So now that we have all these x values, we can go and plug them in. So we know that at C, that is where we're going to have the 7 and 0. And at A, that is where we're going to have the negative 1 and 0. Then at D, remember guys, what happened is the x there at D, we found it to be 1 over 3, while the x here at E, we found it to be 5, right? And then if we now look at what they are saying here, is they're saying the second derivative times f of x must be less than 0. Remember, guys, our second derivative, we found it previously to be 6 minus 16, okay? And the x-intercept, we found it to be 8 over 3. 8 divided by 3. So if we quickly sketch that graph, what you will see is it will be crossing at negative 16. So we'll have negative 16 down there. Then on the x-axis, it will be crossing at 8 over, at 8 over, let me just move this a bit, just erase it. Yeah, there what we have is 2 and 0. Okay, so if you look at where the second derivative graph will be crossing at 2.6, something like that. So what this means is that graph is going to be negative 16. Here, it is going to be something like this. And this here is the second derivatives graph, okay? And the other one is just our f of x. Okay, I hope that you guys actually understand what is happening here. Now, if you observe carefully, you will see that they are saying we want the product where these two graphs, that second derivative and the other one, they are negative. Meaning that is where one graph is above the x-axis, another one is below. Okay, so let's think carefully of what they are saying. You guys see that the other graph will carry on down like this and like that. So if you observe carefully at x, at negative 1, between negative 1 and, if you look carefully, we want where the one graph is below and the one graph is above. So do you guys see that between negative 1 and the other one is above until it gets to this point here at 2, then both of them become below. So do you see that x values between negative 1 and 2 are a solution for our problem? Because one graph is positive while another one is negative. I see a hand, you can ask.
Sir, I was asking for the long division part. What if you don't, your answer doesn't simplify to 0, like you have a remainder? What do you do?
It means that the x value, your factor, this x value, this 2, when you plug it in there, the original expression, it doesn't give you 0. So it means it's not a factor. So if you use a number, let's say you take a guess and you say x is 3, because sometimes you're not giving, you try. When you get the x that will give you a 0, let's say x is 8, then your factor becomes x minus 8. And you should get a remainder of 0 if you don't make any mistakes. But if a, whatever the number is, doesn't give you a 0 when you plug in there, then it's definitely not going to give you a remainder of 0.
Okay. That
Yeah.
means it was a mistake from the A value.
Yes, means the mistake you might have made it from the A value. But if the A value, when you plug it in, it gave you 0, it means you made your mistake when doing long division.
Okay. Thank you.
You understand?
Yes, sir.
Okay, great. So let's go ahead now and quickly put up our solution. Because with a negative, it means you need one graph to be positive while another one is negative. So if you look carefully, we'll have an x value that is between -1 and 2, okay, as one of our solutions. And then now, when we look carefully, you will see that the other graph then starts being positive while our other graph is negative. And this will stop when we are now at 7. So between, remember the x value we found here was 8/3. Okay, if you solve this f of the double prime, you'll find 8/3. So between 8/3 and 7, one of the graph is positive while the other one is below. See, the other one is below while the other one is above. So when you multiply them, you get a negative. So it means we have our other solution to be x is between 8/3 and 7. Okay. And that just becomes our, yeah, our answer. I hope that it does make sense to you guys. So let's go and have a look at the last question. Let me quickly move this down. The page move down. So with these questions, it's really, if you practice a lot, you'll be able to figure them out. So let's have a look at this one. So we are asked for which t values will y equals -11x plus t intersect f at 3 distinct points. So we need to be very careful of what is happening here. So for which x values will this graph intersect our graph at 3 distinct points? So the first thing that we can do is we can figure out the x values where this graph can possibly touch our graph. So let's go to 9.4. So we're given y equals -11x plus t. Sorry. Okay. So there's one of two things we can do. So you guys know by now that there is what we call gradient. Okay. And if you think carefully with what is happening here, if you draw a tangent to this curve, which has a slope that is negative, you can either have a point, let's say somewhere there, where that becomes a tangent, or somewhere, let's say roundabout here. Just think about it. Because if we want a tangent, that is where we are going to draw it. But our tangent is only going to cut the graph, is only going to touch the graph at one point. So what do I mean? If we are able to shift the graph and tilt it a bit such that it's able to cut through 3 points, as an example, if it can get in here and there. So if you observe carefully, x values that can be between the turning point, somewhere in between, will allow us to be able to, the y values that will be, you think carefully, the y values that will be between this point and this point, if we can get a y value that will be somewhere in between, we will be able to cut this in 3 points. So what we are going to do is we are going to find, if we have a gradient of -11, where is our tangent touching the actual graph? And remember that whenever you're looking at the second derivative, guys, this is by definition the gradient of the tangent to the curve by the curve. What we are talking about is f of x at point x comma y. So that is what the second derivative is. It is not the second one, the first derivative. The first derivative is the gradient of the tangent to the curve at a point xy. So remember, our first derivative we did find, which was 3x squared minus 16x plus 5. So we can try and find out when is this expression having a tangent of negative 11. That will tell us where we are touching, or where this line is touching our graph. So if you observe carefully, that means we are just going to solve an equation where we just transpose that negative 11, and we end up having 3x squared minus 16x, and then plus, if you observe carefully, 16. Okay, and this will be equal to 0. And the nice thing with this one is we can just divide by 3, okay? Because, well, you can we? It's going to make our life to be easy. So what? It's not going to make it to be easy. What we are going to do is attempt to solve for x. I'll go the long way, which is using the quadratic equation. So our x is going to be negative 16, and then plus or minus the square root of. What we are going to have is negative 16 all squared minus 4 times a, which is 3, c, which is 16, and all of this is divided by 2 times 3. And if you solve for x on these, you will see that one of the x's will be 4. If you punch your calculator, the other one will be 4 over 3. Okay. Now, if you think carefully of 4 and 4 over 3, remember our turning point here is that x is 5. So if you observe carefully, this talks to exactly what I was saying. So the x is 4 is somewhere here. And remember that turning point there at D, that one was that x is, I think it was 1 over 3. Let me just double check. Where is the other turning point? X is 1 over 3, that's correct. But if you look at what we found, 4 over 3, which is just slightly to the right, which is here. X is 4 over 3. Okay. So now with this, we just need to choose y values. Okay. That will make sure that this, when we intersect, we work out the t values. So let's go and figure out what is the y value at that x equals 4. Or that x equals, yeah, let's start with x equals 4. So if you look at f of 4, of which it is supposed to give us the same value as this negative 11 into 4 plus t. So we can get a t value, okay? So if you look at f of 4, you can, remember f of x is x cubed, so it's this minus 8 into 4 squared plus 5 into 4, and then plus, I think it was 14, yeah. Then this becomes negative 44 plus t. So the left-hand side, if you do your maths and you transpose, what do we get when we do this left-hand side, guys? And then we also transpose the 44. So do the left-hand side, and let's see what you find. What is the y value?
Negative 30.
Negative 30 equals 4 plus t. So you can transpose. And when you transpose, you will see that the t value will become 14. Okay, and this is at this x value. So that is at x equals 4. So at x equals 4, our t becomes 14 for us, for the tangent, which is in red, to be able to touch at that point. Then let's go now at the other point, which is 4 over 3. So what I'm going to do is I'm going to do f of 4 over 3, and this will be equal to negative 11 times 4 over 3, then plus t. So I need you guys to do f of 4 over 3. What does that mean? Means you'll have 4 over 3 cubed minus 8 into 4 over 3 squared, then plus 5 into 4 over 3, then plus 14. So I need you guys to give me what the left-hand side will be. Then for the other one, we'll just have negative 44 divided by 3 plus t. So the left-hand side, what does it become? Should be a fraction.
It's 238 over 27.
48 over 27. And this is negative 44 over 3. So I need you to add 44 over 3 to that answer. Add 44 divided by 3.
634 over 27.
Okay. So you're getting t to be equal to 4 over 7. What is that in decimal place?
23,48.
23.48. So now, if you observe carefully, all what this means, guys, is the following. If we can get our y value, we can now mute. If we can get our to be somewhere between these two values. Remember, what we just found is a y value there. You can now mute. The sound is coming off very strongly. So remember that what we found is our y value here was minus 33 or minus 30. Yeah, which is just that there. And then what we just found above at that point is our y value. We just use a different color, where's orange. Yeah, what we are finding is our y value there is just what we found now, 23.48. So all what we are saying now is if we keep the t value to be something between these two values, then we would have done our job. We keep the t values to be something between these. Because if our t value is a value which is between these two, it means it will cut 3 times. Okay. And that is just the simple idea. So for this, you will just need to spend a bit of some time and just make sure you make sense of what I'm saying here. But the answer here is that t should be between the t values that we find here, so that we are able to cross 3 times, you see. Because if it's above, it means you will cross, probably once or not cross at all. Yeah. So what is our solution to this problem? Our solution is that our t will be between 23.48 and we found 14 and 14. Yeah. So that becomes our answer to this question. Okay. Done with that, guys. Let's go and have a look at the next one. So the next one is the June. The one we were doing before was November. This is the June. Well, yeah, 2025. This is the June exam. We were doing the November exam 2025. Okay. So look at what is going on here. So they are saying we are given that expression there, and we are told that we can simplify this to x minus 4 and x minus k all squared. So now I want you guys to think, if we now have x minus 4, which x value then will make f of x to be 0 by the thinking that we had before. That if you now say x minus 2, where is it coming from? What can we say about the 2? So what can we say about this 4 here? We'll look at 9.1. So we're given f of x equal x cubed minus 6x squared plus 9x minus 4. Okay. So if you observe carefully, this is said to be x minus 4 into x minus k all squared. So what this means is it tells us that x equals 4 is a solution. Is a solution. Okay. What does it mean that it's a solution? It means that if you do f of 4, you will get 0. Okay. That is what it means when we say it's a solution. So now we need to find the other number that is there. So there's a couple of ways we can go around this one here. So the easiest one is we can take k and put it in there and see if it works. Okay. So what we can do, if they are saying show that k is equal to 1, then it means that k equals to 1 is a solution. It is a solution. So how do you test the solution? We should go and test it. So we are going to go and test. Add x equals 1, okay? Because that is what they are saying the k is. So it means I need to do now f of 1, of which our f of 1, if you observe carefully, it will be, sorry, our f of 1 will be 1 cubed, and then minus 6 into 1 squared, and then plus 9 into 1 minus 4. What are we getting our f of 1 as, guys? Just punch in your calculator quickly. We're getting what?
0.
So it comes 0. So we can therefore say that our k is therefore equal to 1. Okay, it's a solution. Now let's go ahead and have a look at 9.2. So 9.2, we are required to calculate the turning point. And we know that once they say turning point,
So
yes.
Why did we substitute on the original formula? Like, I don't understand. Are these factors?
So no. So remember, I said from a solution you get a factor. So if you take x, remember the previous problem, what I said here. I said that if you look carefully here, we're given that we have x is 2. So meaning x is 2 is a solution, but the factor becomes x minus 2. Where did I cover that? So the factor becomes x minus 2. So if you look carefully here, they are saying k is here. So meaning what you have there is x minus 4, then x minus 1 whole squared. So x equals 1 is a solution, meaning when you take it and you put it in here, you are going to get 0. Okay. And if something is a solution, then we get a factor from it by saying 1 minus whatever the solution is. And this now here becomes a vector. Do you understand? Okay, I see. So let's move on then and have a look at this one. So they're saying they want the turning point. And for the turning point, we know we always need our derivative equal 0. So, but when we look at our graph, we need to multiply it first. So we have f of x equals x minus 1, x minus 4, and we have x minus 1 all squared because we know k now. So this means we have f of x equals x minus 4 times x minus 1 times x minus 1. So in order for us to derive, we can't derive it when it is this way. So we need to expand first. Okay. And if we multiply the last two brackets, you guys should have done a lot of FOIL. So the first bracket, x minus 4, the last two, when you multiply them, you'll get x squared minus 2x plus 1, okay? And then now we can multiply these ones. So if you multiply with the x, you get x cubed minus 2x squared, then plus x. And then what you do is you then multiply with the blue. And with the blue, you'll see you'll get negative 4x squared plus 8x minus 4. Okay, and you can therefore simplify your f of x because once it is in this way, we know how to derive that easier. So we have x cubed, and then we have a minus 4 and a minus 2, that becomes minus 6x squared. We have an x and an 8, that becomes minus 8x, and we have minus 4. Okay, that is what we have. So now this is easier to find f prime of so that we can find the turning point. So our f prime, if you remember by our power rule, we'll have 3 x squared minus, you'll times by the 2 to get minus 12, then minus 1, okay? So which means we'll end up with x, then plus 9. And we'll equate this to 0. And in order for us to solve for x, well, we can do a couple of things. We can either try and divide by 3. Okay, we can divide by 3 such that we are going to have x squared minus 4x plus 3 equals 0. And this, guys, is simple grade 9 maths. This will be x minus 3, x minus 1 equals 0. So you'll get x equals 3, or you get x equals 1. So these are the x values of the turning point. Now we need to ask ourselves, what about the y values? And for the y values, we are going to use our function, okay, which is going to be f of, so I'm going to do the one at x is 3. So we are going to do f of 3. And our equation, if you observe carefully, it is 3 minus 4 and into 3 minus 1 all squared. So what we end up getting is what? What is it, guys? 2 squared. That's going to be 4 times. That's going to be negative 4. So this means we have a turning point at 3 and negative 4. Okay. Then we can go and do the other one, which is at x equals 1. So we can do f of 1. And if you observe carefully, we are going to have 1 minus 4, and then 1 minus 1 all squared, which is going to give us 0, which means we have another turning point at 1 and 0. Okay, that is where we have the turning point. And remember, once you have repeated roots, guys, it means that you are going to have a turning point at that root. Or let's say if you have a factor that is appearing twice, like it is a square, at that factor, you are also going to have a turning point. Okay, that is all what it means. So we have found our turning points. We are happy. So they say we should go and describe the concavity of f at x is negative 3. So let's create some space. So what did we say, guys, is the important expression when we are talking about concave up and down? They say concave up and down, or they speak about points of inflection. What should come to our mind? what should come to our minds is the second derivative. Okay, the second derivative at, yeah, it's the second derivative. So let's go and have a look at 9.3. So they are saying concavity. And once they say concavity, what should come to your mind is the second derivative. So it means they are trying to speak about either concave up or down. That is what is happening. Okay. So we have our f of x, which is x cubed minus 6x squared plus 9x minus 4. And what we can do is we can find the first derivative, which we had found before, which became 3x squared minus 12x plus 9. Then we find the second derivative, where you are deriving what is above. Okay. And you get, you times by the 2, you end up getting a 6. So we have a 6x minus 12. Okay. So that is what we have. And remember, now they are asking about the concavity at x equals -3. So what can be said about the concavity at x equals -3? So we are going to go ahead and have a look at our second derivative at -3. So we're going to have 6 into -3 minus 12, which is going to be what, guys? 6 by 3, that's 18 minus 12. Is that -30? Yeah. So what we have is -30. So our second derivative at this point is -30. Do you guys remember what we said about the second derivative when it's negative? We said, is it concave up or down? What did we say?
Concave down.
Yep. So if you observe carefully, you will see that our second derivative at that point is less than 0. And whenever you have it less than 0, what we said is we have concave down when our second derivative is less than 0. So we can therefore put up our conclusion, which is that at x equals -3, at x equals -3, we move this up. At x equals -3, the curve or let's say f of x rather, at x equals -3, f of x is concave down. Okay. And that becomes our answer, guys. Right. And then let's go and have a look at the next question then, 9.4, where we are required to plot the graph and label all the x's. So remember on the previous page, we did find our turning points and our x-intercepts. We know them, it will be at x is that. So let's go ahead and cook. Okay, so what I'm going to do is to start by indicating the x-intercepts. So the x-intercepts, if you remember, we'll have 1 at 4. So we'll have an x-intercept at 4. Yeah, somewhere there. Then we'll have another one, our other x-intercept at 1. So let me move this. So we'll have our other intercept, x-intercept, somewhere here at 1. So that is x is 1. So we have 1, and then we have 4. Now looking at the value of a, guys, there, is my graph going to be the purple one in shape, or is it going to be the blue one?
The purple one.
Yep, it's going to be the purple one. So we did cover that. Now, what you then need to note is exactly what is happening here. So let me put the 1. So because we have a repeated root, and remember our turning points. So let me put our turning points also. So we have a turning point at 3 and minus 4. 1 is at 0, is 1 at 0. So we have a turning point here at 1 and 0. Okay. And we have a turning point at 3 and minus 4. So 3 will be somewhere just below 4. So let's put 3 to be somewhere here. Okay. Let's extend this. So we'll put in 3 to be somewhere there. And we put in the corresponding y value, be minus 4. Okay. And then what you will see is that the the y-intercept, which is when you set x to be 0, it becomes minus 4, 2. Okay. So we are now, guys, in a position to go and draw our graph. And remember, wherever you have repeated roots, it means that your graph has a turning point. So you're just going to go up. So maybe let me move this to the left a bit. Yeah. So what's going to happen is we're going to go up and then 10 there, go down, 10 there, then go up like that. Okay. So that is how our graph looks. Let me try and make it to be a bit neat. Let's move that to the right. Let's give that a try again. You go up. There's your turning point. You go down. There's your turning point, and then off we go. So that is what we were expected to be able to do. Guys, you have your turning points, which we should put. So if you remember, the turning point here is minus 3 and, sorry, it is 3 and minus 4. 3 and minus 4. And that is it. Do you guys have any questions? If you understand, just give me a thumbs up. Okay, see we're happy. So let's go to the next question then. That is question number 9.5. So 9.5, they are saying calculate the maximum vertical distance between AF and H. For X values between 1 and 3. If H is given by this function here. So the first thing that we need to do, guys, is let's find our H, which is minus 2 times the first derivative. So it means our H of X will therefore be minus 2 multiplied by the first derivative. We have it on the left. It is 3x squared minus 12x plus 9. Okay. And if we multiply, you will see that we'll have minus 6x squared plus 24x, then minus 18. Okay. So we're looking for the distance between the two, the vertical distance. So when we're looking at vertical distance, it means we are subtracting y's. Okay. Because once they say vertical distance, what it means is we must subtract the y values. Because the vertical distance will just be the difference between the y values. Okay. So what does that mean? So let's create some space and go and see what that means. So let me just re-choose this graph here, push it up, and let's carry on with this one. Right. So it means we need to subtract the y values. So what I'm going to do is I'm going to define a function. Let's call it g of x. And g of x is just going to be the difference between these two functions. So I'm going to do f of x minus h of x. Okay. And this g of x will therefore be equal to x cubed minus 6x squared plus 9x minus 4 minus, to create some space, minus this h of x. Okay, let's copy it. And let's create some space. We are minusing the h of x because we are minusing the y values. Okay, so it's going to be minus this. And if you observe carefully, then our g of x is going to be this x cubed minus 6x squared plus 9x minus 4, and then plus 6x squared minus 24x, and then plus 18. Then now next, what we are going to do is just collect some like terms from this. So this will be plus 18. Okay. Close, remove that. So let's go ahead and collect some like terms here. So you'll see that our g of x will be x cubed. You'll see that we'll have minus 6x squared and 6x squared. Those will add up to 0. Then you have 9 minus 24. What does that become? 9 minus 24, that becomes what? Negative 15. Okay? So that becomes minus 15x. And then you have minus 4 plus 18. That will become plus what? 14. Okay, that is what we have. So now this is the function that guys will describe the difference between the y values. This would be the function that describes distance. Okay, so now we want to maximize distance. So now if they're speaking about maximizing something, this should ring bells from what we learned a while back in calculus. So you guys remember that lesson. So if they say we should maximize a given expression, what do we do to that expression to find the maximum value?
We derive it then.
Yep, derive it and take the x values, plug them back, and then give them the biggest one. So you're on point. So this means here, what we are trying to do is we are trying to maximize distance. So in our lesson on optimization, we spoke a lot about when they say maximize, minimize, exactly what do they mean. So it means what we need to do here is we need to find essentially the turning point, which if we derive this, you will see that we'll just use your, we'll just derive this simply plus 14. We'll use the power rule. So you multiply by 3 down, we get 3x squared, 15x, that just becomes 15. Derivative of 14, that becomes 0. So we don't usually write that, okay? And this becomes our derivative. And we are going to equate this to 0. So we have 3x squared minus 15 equals 0. So we can transpose and have 3x squared equals 15. And you'll see that we can actually divide by 3. Divide by 3, divide by 3. And what we are left with is x squared equals 5. So we can solve for x by taking the square root of 5. But remember, you should always put plus or minus, which means our solution for x values, it is 2. You have x equals square root of 5, or you have x equals minus square root of 5. Okay? So those are the x values that we have. Now, if you think carefully, we need to figure out which of these x values gives us the maximum distance. Okay? So which of the x values gives maximum distance? So it gives us the biggest distance between the two functions. So what we are going to do for that is we are going to go back to our original function g. So we are going to say g of square root of 5. Okay, so we need to test our answers, test the x values. So I need you guys to go and put square root 5 into that equation. So we have square root of 5 cubed minus 15 into square root of 5, then plus 14. So what do we get?
It's 14 minus 10 root 5. Oh,
Yep,
should I
that is
give it in decimal?
in two decimal places.
Negative 8,36.
We get it 8,3. So now what we need to plot is we are not going to consider this value here. But remember our restriction said for x values between 1 and 3. Okay, remember that? That is what they said there. So meaning the negative one we are not going to consider. Remember, we have a restriction. They say that focus on the x values that is between 3 and 1. So I need you guys to give me square root 5 in decimal places so that we make sure it is within the restriction there. So what is square root of 5 in 2 decimal places?
It's 2,224.
We're getting 2.24. So meaning that is the x value, but the other one is going to be negative. So it means all what we need to do is then now to find the distance by subbing in that which we have done. So what we are supposed to do is find the distance, which is just g at square root of 5. And if you look carefully, we get negative 8.36. So why is it negative? It means that it is negative because maybe we might have switched the order of the graphs. So maybe the other one is at the top, the other one is at the bottom. But what we can conclude is our answer is the following, which is that the maximum distance is 8.36 units. So the maximum distance is 8.36 units. And your teacher will be very happy and proud of you because you're doing great work here. Okay, so with that, let's do this one and then we close off the lesson. Okay, so let's go, guys. This is from the 2024 June exam. So let's go and ace this one. Hope you guys are still following. Are we still okay? Right, so let's go ahead and ace it. Then your homework will be the 2023 question. I see I have a hand. You can go ahead and ask. Was it a hand or you wanted to?
No, sorry, mistake.
Okay, no problem. So let's go and cook this one. So the statement reads, the graph f of x, which is as defined by that equation, is drawn below. They give us E. This, guys, should be very easy. They give us E, and then they give us G, which is the intercept. So one thing I need you to remember, guys, is that when a turning point is also an intercept, it means that we have that turning point appearing twice. Okay? Or when an intercept becomes a turning point also, it means at that intercept we have a turning point. Okay? So what does this mean for us? 9.1. So let me start off by making this important note. Important. And what is this note? This note is that when the intercept, or the x-intercept to be more specific, when the x-intercept is also a turning point, then the factor that we will have is squared. Okay, that is very important. So if you observe carefully at E, what we have there, we have our turning point. But do you also guys see that it is also the point where we have the x-intercept? So we know that x equals 1, -1 is a solution, because if you take the -1 and you plug it into this equation, you will get 0, because it is an x-intercept, okay? It's an x-intercept. But then what we know is we always transpose for the factor. So what you know is that x plus 1 is a factor. But because our x-intercept is also a turning point, therefore what we have is it becomes a square, meaning we are only left with one factor now. But if you look carefully at G, we are given to be the x-intercept. And the value of the x-intercept there, look at G, it is 5, the x value is 5. So that means we can look for the factor. What is going to be the factor at point G, guys? If x is 5. What is going to be the factor?
X minus 5.
Yep. Factor is going to be x minus 5. Okay, so that means we are nearly done with our problem, because now we can compile f of x. So therefore, our f of x will be a into, we have a factor of x minus 5. The other factor appears twice, so it will be x minus 1 squared. Okay, now this is our equation. Now all what we need is to figure out, yeah, what is happening. So now the only thing that we need to find is what? The value of a. So what is a equal to? Okay, so that's the only thing that we need to find. But if we quickly multiply f of x, you will see that we'll have a into, so we are going to have x minus 5. Then I'm going to have x minus 1. But when we multiply that second bracket, x minus 1 all squared, when you do the multiplication, you'll get x squared minus 2x plus 1. Okay, like that. Then now let's multiply this. Now, if you multiply the x into that bracket, you'll get x cubed minus 2x squared plus x. Then we multiply by minus 5. That becomes minus 5x squared. Then plus 10x, then minus 5. Okay, close the bracket. Then you'll see that we can collect the like terms. Okay, such that we have x cubed, then minus, if you observe carefully, 7x squared, and then x and that becomes 11x. Let me see, is that correct? X, that's 1, and then 5, that becomes 10, we get 11. Is that correct, guys? Oh. There's a mistake I made here. Remember, the factor is x plus 1, not minus 1, plus 1. So that becomes a plus. Let me see, that then becomes a plus. Okay, and yeah, let me sort this out here. So I nearly made a mistake there. So let me quickly multiply this back. It's a plus there. So what we'll have is x cubed plus 2x squared plus 1, then minus 5x squared, then minus 10x, then minus 5, like that. So if we quickly collect like terms, we'll have x cubed, and then minus, if you observe carefully, 3x squared, and for that last term, it's not supposed to be 1, it's supposed to be 1x. Okay, so you'll have x minus 10, that will give you minus 9x, then minus 5. Okay, then if you multiply, guys, you will see that our f of x will therefore be a x cubed minus 3a x squared minus 9a x, then minus 5a. So we don't have the a, but if you look at our problem, we were told that minus 5, we have minus 5 there. So meaning minus 5 must be equal to minus 5a. So if you look carefully from the description, you'll see that the constant term at the end should be minus 5. So we should have minus 5, and here we have minus 5a, which means a equals 1, okay? Because when you divide by minus 5 both sides, you end up getting a equals 1. So if now a equals 1, you will see that we have found the solution to our problem, because therefore it means our f of x is now x cubed minus 3x squared, and then minus 9x minus 5. And then now we start looking at the values they wanted. So they wanted a, which a is what is multiplying x cubed, that becomes 1. So we can say answers. So for our answers, we have a equals 1. And then b is what is multiplying x squared, which if you look carefully, it's minus 3. So b is minus 3. And then c is whatever that is multiplying x, which if you observe carefully, negative 9. So c equals minus 9. So we're done with this problem here. So let's go to the next page and see what is happening. So next we're looking at 9.2. So for 9.2, we are told calculate the value of x for which f has a local minimum. So once they say local minimum and local maximum, we know they are talking about us deriving the function, getting the x, and then, but they are saying calculate the x value. So we'll need to check where is it where we have the minimum. Okay, so essentially here, you think about it carefully, all what they are talking about is the turning point. Okay.
So, sir,
Mhm.
every time there's a word local, what does this word local mean?
So local speaks to the kind, if you look carefully, there's 2 turning points here. So if you look around this area, which is local, what is the, you call it minimum value if you look around that turning point? So if you localize this to here, what becomes the maximum value as an example? Okay, so think about local as if you are zooming in, where we are saying, okay, let's look here. What becomes our local minimum? Well, it's going to be here. Okay, yeah. So let's go ahead then and find our turning points. So we have our equation, which let's go and fetch from the previous page. F of x, proper things. Let's put it here and go and find our turning points. And then all what you need to do is to decide which one is the minimum and the maximum. So let's have our f dash here, and I need you guys to give me what it's going to equal to f dash of x. What is it equal to? It would be very easy for you guys at this point.
So it's 3x squared.
Then
Minus 6x. Minus 9.
minus 9. Okay. What we are going to do is we are going to take this and equate it to 0. So let me maybe do it on the next line. Let's copy all of that, paste it here, and then we equate it to 0. And what we are going to do is we will need to factorize this, so it's easier for me to divide by 3, and by 3, such that what we end up having is x squared minus 2x minus 3 equals 0. And this is very simple to factorize. It will be x minus 3 into x plus 1 equals 0. It means we're getting x equals to 3, or x equals minus 1. Okay. So now if you observe carefully, for this question, we are asked to find the local minimum. So remember, when I said local minimum, it's you are just looking at a specific area. Okay. Let's say you focus here. Do we have the minimum point here, smallest value? Or if we zoom in closer to this turning point, do we have a local minimum? No. You think carefully, here's what's happening. Around this point, if we look this area here, what we have is we have a local minimum there. That becomes our minimum in this local area of ours, which is blue. And then when we just create another local area that is just a small community there, you will see that what we will actually have in this community, we'll have a maximum there because that is the biggest value. So we'll have a maximum. Now, if you look at the x values that we found, now you will see that at this point here, we have an x value of 3 and negative 1. So here, clearly the 3 is here, and look at where the negative 1 is. That is where the negative 1 is at. So you can tell that our local minimum, because there's no y value below the turning point in that local minimum of ours. That local mean is at x equals 3. So we are supposed to go and find f of 3, so that we just give them the coordinate. But wait, they said determine the x value. Yeah, we are done. So we have found that. So we can just say conclusion, looking at our graph there. So our conclusion is that the local mean is at x equals 3. Okay, hope you guys understand. So let's then move to the next question, and let's look at 9.3. Okay, so for 9.3, they are saying the second derivative times the actual function, where is it bigger than 0? Well, now let's have a look. And this becomes just graphical analysis. So I need to figure out what is the second derivative first. Then I try and draw that graph. Okay. What is very important here, I will say tip. Always draw the graph. And here I'm speaking about the second derivative. If you looked at the 2025 paper, it also had a similar question. So let's go ahead and figure out what is our second derivative. So we already have our first derivative here. So if I just do our second derivative, you'll see that we'll take the 3, multiply it down, it will be 6x. Then it will just be 6x minus 6. Okay. So let's go and use it. So our second derivative is equal to 6x minus 6. So what I'm going to do is to quickly plot that graph here. Okay. So 6x minus 6, what I want to bring to your attention is that the x value at that turning point is 3, remember? So 6x minus 6 is a graph which it will have its y-intercept at minus 6. Yeah, let me think of something here. So what I need you guys to do is I want to see the y value of this turning point here. So let's go ahead and do f of 3. Okay, f of 3, what is it going to be? We have we have 1 cubed minus b, I think it was, let me go and check. Minus 3 minus 9 minus 5. So minus 3 minus 9, then minus 5. So what do we get as our f of 3, guys?
Sir, why are you substituting 1 instead of 3?
Guys, so y is 1. Now let's put in 3. Net f of 3. There's two ways we can solve this problem. Let's go this way. Yep, we can do this.
Negative 32.
Negative what? 32. Did you say negative 32?
Yes.
Okay. So if we now go and plot this derivative function, you will see that it will be somewhere up there, which will be at minus 6. And then the x value, it will cut it there, it will be x is 1. Then that graph will just be going like that. Okay. So if you observe carefully, we want where when we multiply the graph by the two graphs, we get a positive. So what does this mean? It means both graphs must be negative. Okay. Where or both must be negative or both must be positive. Now let's think of what is happening here. So both graphs, if you look carefully, from here, going to the left, both of them are negative until we get to 0, okay, which means we need to exclude. And remember, the red graph is cutting at 1 here. Okay, so it will be negative if you look from that direction. So it means that we are going to have as our answer, we are going to have any x value that is between 1 and minus 1. Okay, or rather we can frame it this way. We can say that x is an element because all x values this side, the two graphs will be below the axis. So we can say x is an element from negative infinity up until 1, and we exclude it. But then we need to say that at 1, these multiply by 0 and the included sign is not there. So I'm just going to exclude this at minus 1. Okay. So that is just one thing, one way we can write. But we need to look carefully. When again are these two graphs both positive or negative? If you look carefully, after the 5, the other graph becomes positive, but the red one was already positive. So meaning another solution here is x is greater than 5. Okay, so we can just say and x is greater than 5. That's it. Okay, so I hope that you guys actually understand.
Sir,
Mhm.
Why do we have a restriction of x is not equals to -1?
It is because at -1, the other graph has a value of 0. So you'll have 0 times some value, and it won't meet this condition. Because this condition is saying greater than 0. It's not included. 0 is not included. And at -1, we get one of the graphs being equal to 0. You understand that? Look here at point E. You understand?
Yes, sir.
So let's go ahead and, yeah, that problem is done. Let's have a look at the next one, which is 9.5. Sorry, 9.4. So 9.4 reads, for which t values is the graph P of x equal f of x plus 2, only having two distinct positive roots and one negative root? Okay. So we need to be very careful of what is being asked of us here. So we have a graph that we are going to call P, okay? And we are going to add a t, such that we are going to have two positive. Let me go to the next page for this one. Okay, so let's have a look at what is happening then here. I'm going to draw, say, another graph. We're looking at 9.4. So let me quickly have a rough sketch here. This graph of ours. So if you observe carefully, they are saying we need to figure out t such that we are going to have two positive roots. Okay. What does that mean? It means that our graph must cut the side twice. Okay. And then it must have one negative root, meaning it must cut the side once. So essentially, we want our graph to be something like this here. Okay. It's like that, and then it goes like that. That is what we want. And now the question comes, let me try that again. It's terrible. And I'll flip these things. It's easier to move you guys. Yeah. So what they are saying to us is something like this, guys, that we need to try and have a graph that will behave this way. If you observe carefully, what we now have here is two positive roots. Okay, so it means we must be able to raise our graph up, but raise it up such that we have these two distinct roots. And the t, if you look carefully, we have p of x equaling f of x plus t. This t here speaks to a vertical shift. And what I need you to remember is that the value that we found to be here, it was at -32. Okay. Initially, well, yeah, not now. But remember the value that we found here, the y, is at -32. Yeah. So do you guys see that if we move the graph up by not more than 32, this thing will work? Because once you move it, let's say exactly by 32 units up, the graph is going to be touching here at 0. Do you see now that we have one positive root and one negative root if we move it by exactly 32 units up? Do you guys see that? That now you have one positive root and one negative root. You guys understand that reasoning? That if you move it exactly by 32 units up, your turning point will be sitting there. Then you'll have one positive root and one negative root. Are we following? Right. So it means when we move this thing up, the t value should not be more than 32. So therefore, we already have a restriction. Therefore, our t value should not be greater than 32. So our t value should be less than 32. But then we need another, what you call it, restriction. What do you guys think it's going to be? Let's think about it. Think about it. What is it going to be?
Sir,
Mm.
is it T must be greater than 1.
T must be greater than 1. Okay. If t is greater than 1 but less than, so why you think it must be 1?
Yeah.
Mm. Why? Okay. So let me help you. Let's think about this carefully. If you observe carefully, the value that is sitting there, we're at -5. Okay. So I need you to think about this carefully. We want to push everything up, but the -5 we must be very careful of. So if we push things up too much, if we push it up very, let's say too much, because this is at -5. So if you push -5 and you put it here, all what you end up having is your y-intercept just crossing there. So how is this -5 affecting everything? Now let's think about it carefully. Think about it this way. If we push this by 5 units up, how our graph is going to look, it's going to be something like this. Okay. And when it's sitting there, if we push it by 5, do we have 2 positive roots and 1 negative root when our graph is cutting at the origin? That's a question. If we push it exactly by 5, it sits like as I show you. Is 0 a positive root? No. So it means if we push it up, we must push it up such that it's more than 5, so that we can cross somewhere on the y-axis there. Then guess what? We now have 2 positive roots. So it means our t, while we are pushing, it should be less than 32. It shouldn't be more than 32, but it should be bigger than 5. And this here becomes your answer. Do you guys understand what is happening? So it's the thinking behind that you need to make sure that you employ, and you'll realize that these things are not very difficult. So with this said, those are the
Sir,
Hmm?
before you close, can we go back to 9.1?
9.1.
Now let's say you are not given the x-intercept, but you are given the turning point. How would you solve the equation?
So if you were given the turning point, it means you would derive your expression and then take the values of the turning point you are given, substitute them into the derived expression, then you will use simultaneous equations. Does that make sense?
Yes, thank you.
That is, come across a problem, then you'll share it with me, which is of the type you're talking about. But yeah, these are the 3 exams that I had prepared for you guys. I hope they will definitely help you in your understanding of this easy topic called cubic functions. So if there's no further questions, we can pause here for today. Panel